Okay, let's pick up a few areas here. Let me give you a few questions, some possible answers. Once again, I just gave you some basic information. They'll be on your test. The final branches of the interlobular arteries. Okay, once again, what does an artery do? An artery is carrying blood away from the heart, gives rise to the blank that carry blood to the nephrons. So we're going to use the word here. Let me give you this to try to explain it. The final branches of the interlobular arteries give rise to the afferent arteries. Okay, and sometimes we hear the. Okay, let me give you some human anatomy terminology here. Arteries actually carry blood away from the heart. Okay, but inside the kidney, when we go into the kidney, then we don't call those arteries anymore. We call them arterioles, arterioles. Okay, and so it looks like the same word as an artery, except it's arterioles. Okay, now so the afferent arterioles, okay, the final branches of the interlobular arteries give rise to the afferent arterioles that carry blood to the nephrons. So what happens here? Here's your kidney, okay? So here's the artery. Now what does the artery do? The artery is carrying the blood from the heart. Okay, well here comes this blood. Now it's not right from the heart. Where's it at in the kidneys? It's already gone through the systems, so it's still coming from the heart, right? So it's going to go into the nephrons that are going to filter it out. And then after we filter it out, okay, then that blood is going back to the heart because now that blood's been cleaned out. Now it can go back to the heart. Okay, so when we talk about arteries going into the kidneys and into the nephrons, okay, then that's the blood that needs to be filtered out. It's already been through the body, then up in through the kidneys, and then the clean blood is going back to the heart. Okay, all right. Now when we talk about, it says in which area can we term urine? In which area can the term urine be correctly used? So, at what point does the liquid in the body become urine? It's when it's in the collecting duct, D-U-C-T. When we begin to separate out all the liquids in our body, we filter them out of the kidneys. We go through the intestines, especially through the small intestines. We pull out the liquids. So the point at which we start saving those liquids that are not the filtered out, but the part that we have filtered out, we call it the collecting duct, which is now that term now becomes urine. Urine is where we have the collecting duct. Where does most selective reabsorption occur? Okay, where does most selective reabsorption occur? You probably got this from reading in your book. It's the proximal convoluted tubule. Okay, proximal meaning close to us. Okay, convoluted tubule. Without going into a lot of detail, I want to refer you to the drawing. Once again, if you have the 13th edition, that was pretty good. If you don't, you're like, but you'll see doesn't matter where in your book. You'll see a big picture of the combination of the arteries and the veins in the whole urinary system. Okay, so when we talk about once again, where does most selective reabsorption go? Okay, selective means we want to reabsorb good things back into the system. It's a proximal convoluted tubule. I may come back and talk about that in a little bit in the summary. We'll see. Where does most secretion of substances out of the blood occur? Okay, that's in the distal convoluted tubule. Let me, in a little bit when I have my camera person back, we'll zoom in on this and I'll show you what we're talking about in case you see this in case you have trouble finding this in the book. Okay, so I'll show you so proximal means close, distal means future. Is it easy to zoom in, or is it kind of hard to? Let's see if we can zoom in on this picture here, and let's just see if we can get a hold of that. So what this is this is actually the convoluted tubule. So distal means close to, I'm sorry, distal means far away and proximal means close to. So what are we talking about there? We're talking about, it says, where does most selective reabsorption occur? In the proximal convoluted tubule, okay? And where does most secretion of substances out of the blood occur? In the distal convoluted tubule. So what we're looking at here, so we have a red and a blue, arteries and veins, okay? So one of them is reabsorbing and the other one is getting rid of, okay? So that's kind of, and you'll find that in your book, regardless of which edition that you've got, you've already been through that and looked at that a little bit, okay? So let's move on. Okay, now, most small proteins are reabsorbed by what? And the answer is pinocytosis, okay? Most small proteins are reabsorbed by pinocytosis. Cytosis means we just literally, in the bloodstream, we literally surround it, absorb it, and build it, and break it down, and then move it through. Pinocytosis. If you're not familiar with that, you will be once you finish this chapter. Okay, now, within the renal tubule, two hormones play roles in determining the final volume and sodium concentration of the urine. The hormone what? And the answer is aldosterone, okay? Aldosterone, and I'm not pronouncing that correctly, regulates sodium reabsorption, okay? While the antidiuretic hormone regulates water reabsorption. So let's talk about this, okay? The only thing that I hate about teaching this in a short deal is we kind of compact some things in there, and I can elaborate and go on and on. Hopefully you've already picked a lot of this up from your book, but let's talk about the question again, okay? The question said, within the renal tubule, all right? So once again, there's just a lot about kidneys. Two hormones play a role in determining the final volume and sodium concentrations of the urine. The final volume of the urine and the sodium concentration. The hormone, and this is aldosterone, okay, aldosterone, and that's the correct pronouncing, aldosterone. aldosterone, okay, that's the hormone that regulates sodium reabsorption. So the aldosterone is also a hormone that can be messed up for kidney stones. And it's not the only cause of kidney stones, but this sodium reabsorption by aldosterone actually can be a big factor for kidney stones. But it's how much sodium, the hormone, what does the hormone do? A hormone is a chemical switch. Turns on, turns off. How much sodium do we want in? We've got enough sodium. That's too much. Take it out. We need more sodium, allow more in, okay? We talked a little bit about the sodium-potassium pump earlier. Don't want to get back into that, but sodium-potassium, major vital chemical balance within the body. So, then we have, the anti-diuretic hormone regulates water reabsorption, okay? So, what's a diuretic? Okay, anti-diuretic hormone, and that's ADH is the abbreviation, okay, regulates water absorption. So if this is pretty big, and you know, it's kind of, I kind of hesitate as I get to these because I'm like, oh, I've got to tell you about this, and I've got to tell you about that, and I've got to tie all this in. But we got to understand what the word diuretic means, because when your body begins taking in too much fluid, okay, a diuretic releases fluid, gets the water out of your system, okay? So if all of a sudden somebody's kidneys aren't working, okay, or their heart is not pumping right, or something's wrong, or the pH is wrong in your body, and you start to retain major fluids. I'm not talking about a little deal. Some people, you know, sometimes people gain a little bit of weight, they retain fluids. That's not really uncommon. It's not, it happens. But when somebody has too much water in their system, okay, we give them a diuretic. Diuretic means to let the water go, whoosh, okay? So this is called an anti, meaning to do away with that, antidiuretic hormone regulates what? Water reabsorption. Because what does the diuretic do? It takes the water out of the system, and that water goes directly out. If we give you a diuretic, you're going to be going to the bathroom right away. Your urinary system is going to release the water. You're going to actually release water from cells. Your blood's going to release water. Not all of it, but a bunch of it. And the more diuretic you take, the more you're going to wash the water right out of your system. So what we want to do now, so they're saying which one regulates water reabsorption, keeping the water in our system? What would that be? Anti-diuretic hormone. Okay? Diuretics, big thing. If you become anything with medical, a nurse or doctor or anything with medical, you definitely understand what a diuretic is. Diuretic removes water, removes liquid. Our body's not able to get rid of it. We literally can drown in our own water. There's kind of a deal. Can you overdose on water? And the answer is, as long as your body is able to get rid of what you don't need, no, you can't. But if your body gets if you're having kidney problems and you can't get rid of the water, then yeah, you could actually overdose and get too much water. Isn't that crazy? So, once again, big extreme there. Antidiuretic hormone regulates the water reabsorption. What is the plant compound known as inulin? It's not insulin, it's I-N-U-L-I-N, inulin. It says, why is the plant compound known as inulin the best substance to use to measure renal clearance? Okay, and the answer is, inulin is neither reabsorbed or actively secreted into the filtrate. Okay, so what does this mean? Okay, once again, wow, I could just stop and talk about this for a while. Inulin is this incredible plant hormone that we can put in our system. That's not absorbed by the kidneys, and it's not, it just goes directly through our system. It can go through the kidneys. It's not changed. It's not reabsorbed. So I can watch that go through my kidneys. Okay, now listen to the question again. Why is the plant compound known as inulin the best substance to use to measure the renal clearance? By clearance, I don't mean how high it is. I mean to make sure there's no obstructions in there. Make sure there's no kidney stones in there. Make sure there's, all of a sudden somebody is retaining all this fluid or their body's not working. We want to know if the nephrons are working, but we want to know that it's clear, that we can get all the way through. So we've got this neat plant compound called inulin, okay, that we just go right through, and we can time it from the time we drink it, okay, to the time we urinate it out, and look to make sure that we have perfect clearance of our kidneys. And that's kind of cool. All right. So let's do one more here before we get done. Let's do this one. In males as well as in females, the external urethral sphincter is made up of skeletal muscle and is thus under voluntary control. Where is the external urethral sphincter located in males? Okay, and it's within. Okay, let me give you this, and then once again we'll come back and talk about it real quick on the next video. It's within the urogenital genital diaphragm. Okay, so basically we're talking about males and females regulating, being able to have a sphincter that turns on and off the control of urine. Okay, so it says in males as well as females, the external urethral sphincter. A sphincter is a closer. Sphincter is something that opens and closes. It's made up of skeletal muscle. Okay. And is thus under voluntary control, which means we can control that. Okay? So, the good news is, I guess they talk about males, not that they're saying that males can control their bladders better than females, but in the male, it's the urogenital diaphragm that literally allows us to be able to control whether or not we release urine or don't release urine. So, when you gotta go, you gotta go. See you next video.